example 6, using the product rule and the chain rule, we're going to differentiate the function y, which is equal to 2x plus 1 to the 5th power times x cubed minus x plus 1 to the 4th power. Okay, so in this example, we must use the product rule before using the chain rule. So what we're going to do is, in step number 1, in order to find dy with respect to x, then that's going to equal the first function here, which is 2x plus 1 to the 5th power times the derivative with respect to x of the function x cubed minus x plus 1 to the 4th. And then plus the function x cubed minus x plus 1 to the 4th power times the derivative with respect to x of 2x plus 1 to the 5th power. So what that means is we need to look at this first. So that tells us that we have 2 to the x plus 1 to the 5th power times, this is going to be 4 times x cubed minus x plus 1 to the 4 minus 1, which is 3, times the derivative of what's inside. So we need to find the derivative of x cubed minus x plus 1. Okay, then we're going to find the derivative of this. So this is going to be plus x cubed minus x plus 1 to the 4th power times, this is going to be 5 times 2x plus 1 to the 5 minus 1, which is 4, times the derivative of what's inside, which is 2x plus 1. So now let's take a look at this first part. So over here, we're going to write the value of 4 times x cubed minus x plus 1 cubed, and then times the first function, which is 2x plus 1 to the 5th power, and then we got to find the derivative of this. Well, the derivative of x cubed is 3x squared. Derivative of minus x is minus 1. The derivative of 1 is 0. And then plus, again, rewriting the 5, one with the coefficient 5 times 2x plus 1 to the 4th power times x minus x plus 1 times the derivative of 2x plus 1, which is 2. So now here's where the algebra is going to come in handy. Okay, and so what I mean by that is we need to look at this. So we know that this represents an entire function, and there's 2 terms in this function. This entire thing is our first term, and this entire thing is our second term. Now, what does both terms have in common? Well, we both know that we can factor out what they have in common. Well, they both have a 2 in common, and they also have a 2x plus 1 in common. But how many do they both have? Well, they have 5 in the first term and 4 in the second term, so that means we can factor out 4 of them. Okay, and then they also have the x cubed minus x plus 1 in common. On the left, we have it to the 3rd power. On the right, we have it to the 4th power. So that means that to the 3rd power is what they have in common. So we can factor this out. Okay, so if we factor this out, then this is going to be on the outside. 2 times 2x plus 1 to the 4th power times x cubed minus x plus 1 to the 3rd power. Okay, now what's left over in that first term? Well, we know that we have a 2 and a 2x plus 1 times a 3x squared minus 1. Okay, and then on the right side, what do we have left? Well, we have a 5 times an x cubed minus x plus 1. So now what we're going to do is we're just going to have to then simplify this. So we're going to have to multiply, distribute the 2, distribute the 5, and then combine like terms. So if we go a little further here, we have 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 to the 3rd power. So if we multiply this together, we're going to have 2 times, well, 3x times 3x squared is 6x cubed. And then we have minus 2x. We have plus 3x squared minus 1 plus 5 times x cubed minus x plus 1. And now let's go ahead and distribute that. So again, we still have 2 times 2x plus 1 to the 4th power times x cubed minus x plus 1 to the 3rd power. So if we distribute the 2, we end up getting 12x cubed minus 4x plus 6x squared minus 2 plus 5x cubed minus 5x plus 5. And now this is going to be one term, so we're going to leave this. So we're almost finished here. So we have 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 to the 3rd power. So if we combine like terms, we have 17x cubed. And then we have plus 6x squared. Then we have minus 9x. And then we have plus 3. So therefore, this is the derivative of that function.